Hey everyone, this is lesson 9.3 and 9.4, transforming functions and operations with functions. Your objectives for today, you're going to be able to add, subtract, multiply, and divide functions. You'll also be able to write and evaluate composite functions. The vocabulary for this lesson is composition of functions. All right, so in this example, we're going to talk about combining transformations. So we are given f of x equals 1/3 times x minus 2 squared. And then we're also given g of x is equal to 2 times f of x minus 3. So we're supposed to take these two functions and we're going to graph g of x. So what do we do? Well, first of all, it says to take 2 and multiply it times f of x. So I'm going to take 2 and I'm going to multiply it by f of x. Well, f of x is equal to this. All right, so I'm just going to say 2 times 1/3 times x minus 2 squared. All right, and so that is equal to actually 2/3 x minus 2 squared. And then I just have to subtract my 3 from it. All right, and that's as far as we really need to go on this problem. We could multiply it all out and do all of that, but we really don't need to. It's a lot of extra work. So all we need to do now is just make a little t-chart, and let's plot some points, x and y, and let's make some decisions here. Let's say when x is 2. 2 minus 2 is 0. 0 squared is 0 times 2/3 is 0 minus 3. So it's y is going to equal -3. All right, we could also try 5. Let's try 5. 5 minus 2 is 3. 3 squared equals 9. All right, 2/3 times 9 is actually 6. And 6 minus 3 equals +3. All right, so that's when x is 5. All right, so let's just take a look at our graph. And I've already written out the graph of 1/3 f of x. This is f of x. And let's take a look at where g of x is going to be. So far we know that we have a point at 2, -3. So that's all the way down here. And my next point is at 5, 3. So 5 up 3 is right here. Now, I know since this is a parabola, it's going to be symmetric around the axis of symmetry. So I know that if 2, 1, 2, 3 is up here to 3, then I can go the other way, 1, 2, 3, and also have another point here. So now that's really all I need to do to graph my new point. And there it is. All right, let's combine another set. Here it says take f of x, and we're going to take g of x, and it's going to be -1/2 of x times f of x, and then we're going to graph g of x. So let's just go ahead and graph f of x just to have that written here. We can see that that's 2 of x, and then we move it down 4 units. And so now we're going to take g of x, and g of x says take -1/2 times f of x, and f of x is 2 raised to the x power minus 4. All right, so in order to graph this, let's just do a quick t-chart, x and y. When x equals 0, that would be 2 to the 0 power is 1 minus 4 equals -3 times the -1/2 equals +3/2. All right, when x equals 1, we're going to have 2 to the first power, which is 2, minus 4 is -2, times -1/2, 2's crossed out, +1. So 1, 1. All right, let's do a couple of more. Let's say when x is 2. All right, 2 squared is 4, minus 4 is 0. 0 times -1/2 is 0. When x is 3, 2 to the third power equals 8, minus 4 equals 4 times -1/2. That's going to be -2. Let's see, let's get this right. When x is 3, y is -2. And we'll just do one more. When x is to the fourth power, that would be 16 minus 4 equals 12 times a -1/2. that's going to be -6. So when x is 4, y is -6. Okay, and let's just plot our points here and take a look at what this is going to look like. We have an x at 0, 3/2. So that's 1.5. So there's our first point here. And then we have a point at 1, 1. We have a point at 2, 0. A point at 3, -2 down here. And a point at 4, -6, so down here. So you can see that our graph is going to be doing something like this. All right. And the final result is just like that. Okay, so now that we have done that, let's move on. All right, you can perform operations on functions in much the same way that you perform operations on numbers or expressions. You can add, subtract, multiply, or divide functions by operating on their rules. And so here are some ways that we're going to do this. If we want to do addition, we can take f plus g of x, and it's really just the same as f of x plus g of x. Or subtraction is just like f of x minus g of x. We can actually multiply f of x times g of x, and we can even divide. Okay, but we just have to be careful that we check to make sure that x isn't 0, because we don't want to have an undefined answer. Okay, so our first example says to take f plus g of x and add them together. So the first thing we want to do is simply substitute f of x plus g of x. So here's our f of x right here, and our g of x is right here. We put them together. All we have to do now is add our like terms together, and we're finished. That's all you have to do. On this particular one, it's not really anything that we're going to, there's no two numbers that multiply together to get 4 and add together to get 9, so we're finished. Now we're going to subtract, same thing. Okay, so we're going to realize that it's f of x minus g of x. So we're just going to substitute the functions in. So here's my f of x, and here's my g of x. The only thing you want to be careful is remember this minus sign has to distribute to both pieces. So it's going to have to be minus 6x minus 2. Okay, you have to get that minus sign to both of them. All right, and now once you've done that, all we have to do is combine our terms together. And again, there's your final answer. Nothing very hard about that. I think you can do that. In fact, why don't you try this one on your own? Turn your video off and give it a try. Okay, again, you should have easily just realized what we needed to do. Substitute the functions into each of them. 5x minus 6, that's our f of x. We're adding plus, and then here's our g of x. And once we do that, then we can combine our like terms. And notice my 5x and my 5x cancel out, my -6 and -6, just leaving me with x squared, and that's your final answer. All right, try a subtraction one on your own. Turn the video off for a minute and give it a try. All right, again, I think you can find these to be pretty simple to do. We're going to just realize that we're going to take f of x and subtract it from g of x. So here's my f of x, which is 5x minus 6 minus this whole term. So remember, I have to distribute that negative sign to everything. So that is going to be a minus. That's going to change a minus. A minus changes it to a plus, and that's going to change that plus to a minus. Now that you've done that, all you have to do is combine your like terms, and there's your final answer. When you divide functions, be sure to note any domain restrictions that may arise. We don't want to have any undefined equations. All right, next we're going to multiply, and again, it's just very simple. We're going to fill in, substitute the function rules for each f of x and g of x, and then we're going to multiply them together. So you can multiply them however you want. I know I'm going to go ahead and show you this way with this box. It sometimes makes it a little neater to me, but it's up to you, however you want to do it. We have 6x squared minus x minus 12, and all that's going to be multiplied by 2x minus 3. And we can just multiply these terms together. 2x times 6x squared is going to be 12x to the third. 2x times negative 1x is negative 2x squared. This is going to be negative 24x. Negative 3 times 6 is negative 18x squared. This is positive 3x and 36. And when we add them all together, we end up with 12x cubed, which is right here, negative 18x squared right there, negative 2x squared plus 3x minus 24x plus 36. Combine all your terms together, and there you are with your final answer. All right, and if you want to distribute each your 6x by everything and your x, however you want to do it to get your answer, works out fine. All right, and this one is division. Again, the very first thing we need to do is realize that we're just going to say the function f of x divided by the function g of x. We want to set up a division as a rational expression, and you know how to do that now. Remember, always factor first, factor first, factor first. And in the interest of time, I've gone ahead and factored it for you. And it's going to be 2x minus 3 times 3x plus 4. And notice that x cannot be 3 over 2, because if it does, then that makes our denominator be a 0, which is undefined. All right, next thing we can see that it's easy to divide out common factors. We do that, and we end up with simply 3x plus 4, where x cannot equal negative 3 or positive 3 over 2. And that's all you have to do. All right, try this one on your own. It's just multiplication. So turn the video off and give it a try. All right, the first thing you should have noticed is all you have to do is take the function f of x and multiply it times g of x. We're going to use the substitution function rules. And then I want you to just FOIL that and multiply it out. Once you do, you have your answer. There's nothing else we have to do with this. So hope you found that pretty easy. That's all as far as you need to go. There's no more factoring that we can do on that. All right, the next one to try on your own is division. So go ahead and turn your video off again and give it a try. Okay, once again, you should have just realized that that's the same as g of x divided by f of x. So we're going to set up the division as a rational expression. Remember, factor first, and I notice x squared minus 4 is the difference of two perfect squares. So x plus 2, x minus 2, all over x plus 2. And let's make sure we realize that x is not going to be able to equal negative 2. Otherwise, it'll be undefined because I'll have a 0 in the denominator. All right, so I'm going to divide out my common factors, and my final answer is just simply x minus 2, where x cannot equal negative 2. Another function operation uses the output from one function as the input for a second function. This operation is called the composition of functions. The composition of functions f and g is notated like this: f circle g of x, okay? And it actually means take the function of f of g of x. All right, so the domain of f composed with g is all the values of x in the domain of g, such that g of x is in the domain of f. So let's see what that really means. Not near as complicated as it sounds. All right, so when you see a composition of functions such as this, it's read f of g of x, f of g of x. All right, be careful not to confuse the notation for multiplication of functions with composition, okay? There's a little dot in there, a circle, when you're composing, all right? If you're going to compose a function, f of g of x, you put a circle. If you're multiplying, you either put them just right next to each other or you put a little dot in between. All right, so now we're going to be evaluating composite functions. So the first problem says to take f of g of 4. And what we want to do then is find g of 4 first. All right, so what is g of 4? Well, g of x is 7 minus x. So in place of x, we're going to fill it in with 4. All right, anywhere you see an x, we're going to fill it in with whatever was in here. So 7 minus 4 equals 3. So now all I have to do is find f of 3. Well, f of 3 was f of x is 2 to the x power. So f of 3 is 2 to the third power. So 2 to the third power equals 8, and that's all you have to do. So f of g of 4 equals 8. All right, here's a different one now. It's g of f of 4. So the first thing again we're going to do is do g f of 4. And f of x is 2 to the x power. So we're going to do f of 4. So everywhere we see an x, we're going to fill that in with 4. All right, so we're going to find f of 4. F of x is 2 to the x power, so 2 to the 4th power equals 16. Now I'm going to find g of 16. All right, so I'm just going to put this 16 in place of f of 4. And because f of 4 equals 16, so now g of 16. So now I'm going to use my rule, which said g of x is 7 minus x, and so 7 minus 16 is negative 9. So finally we can say g of f of 4 is equal to negative 9. Okay, turn the video off and try this one on your own. All right, so the first problem says find f of g of 3. So the first thing we want to do is find g of 3. G of x is x squared, so we're going to fill in place of x, we're going to put 3. So when we do that, we see 3 squared equals 9. So g of 3 is equal to 9. So now all I have to do is find f of 9. So everywhere I have an x up here, I'm going to put in 9. So here we go. 2 times 9 minus 3 equals 15. So f of g of 3 is equal to 15. Another one to try on your own. This time you're going to do g of f of 3. So turn your video off and try this one. Okay, so again, we're going to take f of 3 first. So we're going to take f of 3, which is 2x minus 3, and we're going to substitute 3 for all the x's, and in this case we just have 1. So 2 times 3 is 6 minus 3 is 3. So f of 3 is 3. So now I just need to find g of 3. So g of 3 is x squared. G of x is x squared. So we're going to fill in our 3 for our x. And when we do that, 3 squared equals 9. So what that tells us is g of f of 3 is equal to 9. I hope you didn't have very much problem with that. That's pretty simple. You can use algebraic expressions as well as numbers as inputs into functions. To find a rule for f of g of x, substitute the rule for g into f. All right, so now we're going to be writing composite functions. Again, it's the same thing, just a little bit more complicated, but it's not any more difficult. So it says take f of g of x. So g of x, we're just going to substitute this piece right here. So when we do, we're going to substitute that rule, and we're going to now find f of x minus 1 minus x. All right, so we're going to fill that into our original equation. So anytime we see an x, we're going to have to fill this in place of it. So here it is. We're going to use rule for f. And remember, we need to note that x cannot equal positive 1. Otherwise, we get a 0 in our denominator, and it's undefined. So here we go. I went ahead and I filled in x minus divided by 1 minus x squared minus 1, which is what my problem of f of x said. All right, now, if you were to work that all out, you would need to be saying x over x minus, 1 minus x, and we're going to square that. So that would be times x over 1 minus x again, and then we're going to subtract 1, but remember we need to get a common denominator, and it gets kind of busy, so I've already done it for you. When you simplify that all out, you end up with negative 1 plus 2x divided by 1 minus x squared, and that's your answer. This is the only part that's just tedious and time-consuming, but the rest of it I think you should find to be relatively easy. Okay, let's try another one. Oh, and don't forget, the domain can't be x is equal to 1, cannot equal to 1, or it could be written in this way because g of 1 is undefined. All right, so in this example, again, we're going to go ahead and use our same numbers again, but this time we're going to find g of f of x. So first of all, let's find what f of x is. F of x, we're going to substitute to be x squared minus 1. So we're actually finding, we're going to substitute the rule f into g, and we're going to say, what is g of x squared minus 1? So what that tells us is we're going to take this, and in place of x in our problem up here, every place we see x, we have to replace it with x squared minus 1. So I'm going to put an x squared minus 1 there and an x squared minus 1 here. Let's take a look at that. So we're going to use the rule for g. X squared minus 1 divided by 1 minus x squared minus 1. Now let's remember this minus sign has to be distributed to both pieces. So I end up with x negative x squared plus 2. And now I want to make sure that that doesn't equal to 0. So let's just go ahead and set it equal to 0 so we can solve. So let's go ahead and subtract 2 from both sides, minus 2. So we have negative x squared equals negative 2. Divide both sides by negative 1. We end up with x squared equals 2. So x, we can square both of those pieces. So x is going to equal plus or minus square root of 2. So when x equals plus or minus square root of 2, it equals 0. And so we can't have that. So that's the only time that our x cannot equal. If x is plus or minus square root of 2, we get 0 and the whole thing's undefined. All right, so let's keep on moving. When we simplify everything out, we have x squared minus 1. All of that divided by 2 minus x squared. If you look over here, just rewrote it a little bit, and that's your final answer. Next, we need to talk about the domain. So the domain of g of f of x is x cannot equal 2 plus or minus the square root of 2, or it could also be written this way, because when f of square root of plus or minus 2 square root of 2 equals 1, and g of 1 is undefined then. All right, so try this one on your own. You're going to find f of g of x. So turn the video off and give it a try. Okay, so on this one, again, you should have realized that we're going to substitute rule g into f. So we're going to say, what is g of x? Well, g of x was square root of x plus 2. And so we're going to say every time we see an x in our f of x, we're going to replace it with 3x square root of x plus 2. So here's my 3, here's my square root of x plus 2 minus 4. All right, we're going to distribute, and we need to make sure that we realize that x cannot be, it has to be greater than or equal to 0 because we can't have imaginary numbers. So we distribute on through, and we get 3 square root of x plus 6 minus 4. When we simplify, we get 3 square root of x plus 2. All right, so the domain of this is x has to be greater than or equal to 0, or it could be written in this way. Okay, here's one more for you to try on your own. Turn your video off and give it a try. All right, this time it says we're going to substitute, we're going to say g of f of x. So this time we're going to say g of 3x minus 4, and everywhere that we see an x, we're going to have to replace it with the 3x minus 4. All right, so once we replace that, we also take note that x has to be greater than or equal to 4 over 3. Otherwise, it becomes imaginary or undefined. And multiplying that on out, there we go. And so you're finished already. So the domain of g of f of x is greater than or equal to 4 over 3. You could write it either way, it's fine. All right, and we're headed towards the end of the lesson now. So if you want to turn your video off and do these 4 problems real quick as a quick review and make sure that you understand everything. All right, I hope that you took the time to do those. And here are the answers for number 1, 4x squared plus 2x minus 2. For number 2, 8x to the third minus 4x squared minus 2x plus 1. Number 3 is 2x plus 1, and x cannot equal 1/2. and number 4 is 29. So if you have any problems with those, bring them to class and we'll go over them to make sure you get those right. Here's a couple of more problems that you can do. This is composite functions, f of g of x, and so go ahead and do those. Turn your video off again and give it a try. All right, and your answers are here, and your answers are here. So I hope that you were able to do those. Again, if you are confused, then make sure you bring them to class tomorrow and we will work on them again. All right. Well, that is the end of our lesson 9.3 and 9.4, transforming functions with operations. I hope you guys have a great day, and I will see you very soon. Bye.